Hello and welcome to Mechanical Engineering at the University of Dundee. My name is Dr. Keith Johnson and I am the Programme Lead for Mechanical Engineering and also Mechanical Engineering with Renewables. So before I talk a little bit about the programme, I'm going to just mention the Teaching Excellence Framework. So this is known as the TEF and was first introduced by the government way back in 2017 and was designed to illustrate universities for their excellence in teaching. So pleased to say that University of Dundee we've achieved the highest possible award, which is the Gold Award for teaching. So to talk a little bit about the programme in a bit more detail and what you would achieve or what would you complete if you come to the University of Dundee. Well, one of the unique aspects about our course is the amount of practical based projects. So you get to spend a lot of time in the labs designing and creating objects as opposed to traditional taught lectures. So we have lots of modules such as mathematics and thermodynamics and waste mechanics, but the project element for this, for example, is an engineering project. So an example of the project you might do when you come to the first semester would be to create a wind turbine. So to build and create your own wind turbine. So the idea of this project is to build a turbine in groups together and design the blades to determine the correct number of blades to create a most efficient turbine. So it's a group project and it's quite a fun competition over a few weeks for the students to complete. Other examples of the practical elements in first year where we have an introduction to robotics, and we do this through the university edition of LEGO Mindstorm. So we've got lots of different examples of robots that have been designed and built here. But at the heart of the LEGO Mindstorm, we have the brick, on which you can connect various different sensors. And you can sensors such as touch and color, for example. We get also a little bit of introduction to programming. So you might have had some programming in your school, but we have our version where we have what's known as a lab view type program where we have a drag and drop style interface. We begin to learn about the basics. So again, this is a bit of a group project where the students work together and they design a robot to follow a line and pick up objects from one part of a course to another. It's not assumed that you know anything about coding whenever you come to university, just to make that clear, but you begin to learn all you need at university through all of the different levels within the program. Other examples of practical projects where we get a little bit of an introduction to 3D printing or additive manufacturing. So some of you maybe have been introduced to 3D printing in your schools before, but in the university we have lots of different types of 3D printers available for the students to use. So we have an introduction to CAD, so we get a browser-based software called Onshape where you can design a model. So you can see a bike frame here where you can import that bike frame into a slicer software known as Cura. And you can understand a little bit about the 3D printing process where you can change, for example, the printer speed or the infill density of the model and create lots of different types of prototypes. So it's all about understanding that process of design, 3D printing to create various different types of prototypes. In the second year, it's more core understanding to the mathematics and some physics-based modules, but there's a lot of lab-based modules as well, such as understanding fluid dynamics. You can see here an experimental setup or thermodynamics, where you can see the students get to carry out lots of different experiments using dedicated equipment. Practical element in the manufacturing project, you can see we've got an example here of a video where students have designed a mechanical clock. So it's purely mechanical elements were designed using a CAD program and then laser cut it out and put together. The idea being that the groups need to create this clock to keep time within 2 minutes, which is actually a very difficult thing to do, but it's quite a fun project. In the second year, we begin to learn a little bit more about industry software, which is very important for employment, where we learn about SolidWorks. So SolidWorks is a computer-aided design program where you begin to design parts, put them together to make a functional assembly. And you can see lots of different models that have been designed here, such as robotic hands, helicopters, and automotive parts, for example. One of the interesting things about second year module is that we're accredited for SolidWorks for students to take a test. That means if you pass this test, you're actually listed on a global database and you have a recognized qualification in CAD design, which is very desirable for employment as well. SolidWorks, I just mentioned it a little bit as well in terms of simulation. So you can see different simulations here that have been carried out where you create a design and you can understand stress that's been created in design, these areas of red or fluid flow or heat transfer, for example. And you learn about this process inside of the second and third year. Second year, another key component to the project element is to be able to understand how we can develop or make prototypes using electronics. So we understand a little bit more about microcontrollers, and we connect various different types of sensors to them to make lots of different types of prototypes. And you can see some examples the students have created here to a robot with a microcontroller at the middle of it and sensors that have been attached to it. Again, you don't need to know anything about this beforehand, but it's just to give an example of the kind of things you would learn and the kind of things you can complete during the program. Laboratory experiments, touched on it a little bit more before in fluid mechanics and thermodynamics experiments, but as an engineer, you really need to understand materials. It's very important. And we have lots of dedicated equipment for you to be able to use this throughout the engineering materials to understand things such as tension, where we pull something apart, fatigue, creep, and you can see some of the examples of the types of lab equipment you can use here in practice. In third year, one of the important elements is where you get introduced to industry for the first time. So understanding how to work with industry and how to present solutions. And you do this through the problem-solving industrial visit. So we've got lots of industrial members connected to the program. In the third year, the students get to go and visit an industrial partner, get a visit of their facilities, and the partner gives them a real-life problem to solve. So the students work together in teams, they go away to develop a solution, and they go back and they communicate with industry, and then they present their solutions at the end of the 10 weeks. It's always very well received with the students, so they always enjoy it. And a lot of the students actually go on to work with the companies over summer placements, and these students also go on to get full-time employment with the companies. So just to give you a bit of an example of the types of companies that are connected to programs, we have larger companies such as Rolls-Royce, Jaguar, Sony, BP. So you probably heard of these companies where students have went on to work for. We also have smaller companies as well that are based in Dundee, such as NCR, and I believe Shannon here is part of a fourth year student that's got an employment there at that company. Our students also work with other companies such as Dover Fueling Solutions. So that's the company who make the fueling pumps and petrol stations, and some of the students are working with Dover this year actually to make petrol pumps that have antimicrobial properties, so it prevents the spreading of disease, which is very relevant for COVID-19. Engineering design, understanding about microcontrollers a little bit more and about programming. You'll be learning this during the modules itself. Understanding about how to create a prototype. So to do that, you need to understand how to create an electronic circuit. So you've got an example of schematics here and different printed circuit boards or PCBs that have been created using a program called Design Spark. Other parts of it, for example, more digital needs for companies or industries these days for mechanical engineers, where we use Weebot simulations for robots, where you can design a model in CAD, import it, and then also simulate its movement in virtual. And you can also balance this against a practical model that's being created. MATLAB is I'm not sure if you've heard of MATLAB, but it's very useful software for industry. And we have an introduction to MATLAB through Simulink and programming, where you can create in a simulated model, such as a 3D robot here, against a practical robot, where you understand how you can move things for automotive purposes, for example. In the fourth year, as we mentioned, Robert mentioned briefly, there's an individual research project, and this takes a large amount of fourth year. So if you had an idea in your family or in yourself that you want to create a mechanical engineering project, now really is the time to carry it out. So I myself am interested in many different things, and one of them is cycling. So some of the projects I create, or can the student develop a low-cost parameter, so one they can afford themselves? Or, for example, in Parkinson's disease, where the patient has got an essential tremor of about 10 hertz, can we develop a device to go onto the hand to be able to minimize that tremor? Other types of projects, and this is just a few of the selection that's available, is, for example, where augmented and virtual reality are becoming very much part of industry. But if you put on an AR headset, you can project a hologram and you can design using your hands, which is quite fatiguing over time. So how can we increase the ability to design using different types of controllers? Or indeed simulation, where if you create a bike frame and you apply forces to it, it causes stresses within the frames, and we can simulate that using specific software called SolidWorks. One last introduction to the software skills that are very useful for industry. For example, if you're a simulation engineer and you graduate, where we get an introduction to ANSYS here, and we can understand how fluid flows over different designs. We got a Formula 1 car here, for example, through CFD. Oh yes, sorry, the last part is these are more complicated sections. You learn this in the 3rd and the 4th year, and believe me, you learn all about the theory and the practical elements as well, but we get an introduction to LabVIEW. We do some more experiences about understanding vertical takeoff and landing, in particular to control, which is a specific module within the programs as well. So Robert mentioned briefly that we have an academic partnership with CERN, which is great. The students between the 3rd and 4th year, they have the opportunity to go and visit Switzerland, so get a tour of the facilities and also get a research project, which is based with CERN as well. So I believe in the 4th year this year, we have got 5 honours students that have projects with CERN, and some of them are ranging from creating autonomous robots to working on systems to be able to aid cooling inside the facilities itself if the cooling system would fail. I guess for you guys, you might have heard of Formula Student team as well. So we have got our own Formula Student team, which is called Drive. And you can see some of the cars that have been created by the students here over the last few years. On the top right, we've got a car called Nina, which is created by a team that went to Silverstone. So the idea is it's a student-led society where the students design, build and test the car, and they bring the car down to Silverstone typically after the GP Grand Prix in July, and they race against the other universities, and they also meet lots of different students in other universities as well. So it's a great place to socialize and to learn about other drive teams, for example, or Formula teams, but also to work with industry and to find out the different people that are looking for jobs as well. So there's quite a few different societies within Dundee, and as you're a student, please get involved with them. They're a great way to get social aspects of things, but within engineering we have a couple of specific. So we've got Drive Dundee. We also have the Aeronautical Society. You can see a picture of the guys here on the bottom left, where they actually get to build an autonomous drone, which has to take off and land by itself, which is quite a difficult challenge. And we also have the Dundee University Engineering Society, which I believe Shannon's a part of. I'm going to talk a little bit more about it. Just in case ranking is important to you, as it is important, you'll visit a lot of different open days and universities talk about their rankings, but for University of Dundee, just a few rankings that are important. We have the Times Higher Education, so it's the World University ranking. Very pleased to see that Dundee University has been ranked top in Scotland, and that's in the Golden Age ranking. So that's within 271 institutions from 49 countries. Also, in terms of the graduate prospectus, so we are first in Scotland, so that's from the Times and the Sunday Times Good University Guide in 2021. And another interesting ranking is that we are top in Scotland for the proportion of graduates entering highly skilled employment. So that means that the graduates graduating from mechanical engineering from Dundee are really much sought after by the industry, and we have industrial partners that the students go and get jobs with, but also they get highly skilled jobs when they do graduate and get employment. So that was a brief introduction to the program. Hopefully you found that interesting, and if you have any questions about anything I just said, please feel free to put them in the chat. Otherwise, there is some social media platforms that you can also get us on. So we're on Twitter and we're also on Facebook through these links as well.